Alright, picking up where we left off in the last video on number 29, we want an expression for the area of triangle 1. So we want half of the base times the height, where the base is y and the height is x. And for triangle 2, so our base and height would be the legs, since it's a right triangle, so the height is z and the base is z, so half of z times z. And triangle 3, half of the base times the height, so half of x is the base, y is the height. So there is an expression for each area. Now to get this total area, we would add those three areas together. So we could take triangle 1, which we can also write as xy. Yx and xy are the same. Plus half of z times z, well that would be z squared, plus half of xy. So that's my total area. Well, I'm going to set this equal to the total area of the trapezoid, because they should be equal. These three areas added together should be this entire area, which from earlier we got half of x squared plus 2xy plus y squared. Now we're just going to see if we can simplify anything here. Well, if I multiply both sides by 2, what happens? So I multiply each term here by 2. 2 times a half is 1, and I get xy plus z squared plus xy. And if I multiply this side by 2, since this is all in parentheses, I'm just multiplying the 1/2 by 2, so 1/2 times 2 is 1, so it cancels out, and I'm left with this expression. Let's simplify this. Xy plus xy is 2xy plus z squared. Everything stays the same over here. And then our final step. Since we have 2xy on both sides, we can eliminate it. We can subtract 2xy from both sides, and we're left with z squared is equal to x squared plus y squared. So from our formulas for areas of triangles and trapezoids, we were able to prove the Pythagorean theorem, that x squared plus y squared will in fact be equal to z squared. For number 31, find the perimeter and area of each figure in feet, round to the nearest tenth if necessary. So to find the perimeter, we need the length of all four sides here added together. Okay, so we're going to split this up. Since from here to here is 8, if I draw another perpendicular segment to this other base, then from here to there would be 8. The total is 12, so if I subtract 8 from 12, I get 4. So this length plus this length should have a combined length of 4. If I split that in half, then each of these is 2. Now let's look at our right triangle here. I have a 30-degree angle, which means that it is a 30, 60, 90 triangle. If we know the side opposite from the 30-degree angle is 2, that's our short leg, we need to find the hypotenuse. So for a 30, 60, 90, take the short leg times 2 to find the hypotenuse. And since this is congruent to this leg, this will also be 4. Now we can find our perimeter. So this entire side, remember, is 12. 2 plus 8 plus 2. So we have 12 plus 4 plus 8 plus 4. And that would have a combined perimeter of 28 inches. Now we also need to find the area. So we need half of the height times base 1 plus base 2. So we know everything we need to except for our height. Our height is the long leg of the 30, 60, 90. So to find the long leg, you take the short leg and multiply it by the square root of 3. So our height is 2 times the square root of 3. And substituting in for area, we have 1/2 times the height, or 2 square root of 3, times base 1, 12, plus base 2, 8. If I simplify here, 1/2 times 2 is 1, so I get the square root of 3 times 20. And using a calculator, the square root of 3 times 20 is approximately 34.6. So in square inches, we have 34.6. Let's go ahead and get this into square feet and get our original answer in feet, because that's what it says. Find the perimeter and area of each figure in feet. So if we have 28 inches and we divide by 12, we would get 2.3 feet for the perimeter. Now, for the area, we cannot just divide by 12, because 1 square foot, so that's 1 foot on each side, would be 12 inches by 12 inches. So if this is 1 square foot, that's 12 times 12, or 144 square inches. So we have to divide this by 144 to convert to square feet, and we get approximately 0.2 square feet.